Hello. Right, what we're going to look at today is more solving of trig equations. So our title is Solving Trig Equations Using Cast. Okay, right. So far, and so I'm expecting you to have completed question 2 in exercise 10E to be able to do this lesson. So far, what we've been doing is we've been solving equations like, so our examples so far. So again, I'm not enjoying that thick pen. So something like the cos of x is minus 0.8. And what we've been looking at is this classic range of your angles between 0 and 360. So essentially, if we're drawing a little sketch of the curve, that's all that we're doing, okay? We're just looking at the little chunk of the curve that goes between 0 and 360. So there's my little sketch of the curve. So if I was going to solve this, the method that we've been using, the method that we've been using is this cast diagram. Okay, it's cos and it's negative. So you circle the quadrants where cos is negative. Now cos is positive here and here. So it's negative here and here. You then get your calculator and you find your acute solution. You've dealt with its negativity, okay? So you can now just ignore the sign. You're taking that absolute value. So all you do on your calculators is you inverse cos 0.8, so shift cos 0.8, and you've got the angle, so your acute solution is 36.9. Now that may or may not be a solution, and you can see here it's not a solution because that's an acute solution, it would be positive. You then draw this angle into the ringed quadrants from your nearest x-axis. So this ringed quadrant's nearest x-axis is here, and this ringed quadrant's nearest x-axis is here. And then to get your solutions, you go to 0 degrees and you read off. So there's our first angle, 180 minus 36.9, which is going to be 143.1. And your second solution is 180 plus 36.9. So that's going to be 216.9 degrees. So that's what we've been doing. And the only thing that's been we've had to really make the difference between is whether or not it's a negative number here or whether it's a positive number. So what you're going to do in the lesson today is we're going to do this for different ranges. Okay, so I'll explain what I mean. So our first example, so example 1, and again, let's make that pen a bit thinner. We're going to solve the sine of, we'll have theta this time, is 0.7. And this time, our range, oh no, I don't want to do that. I want to change the range. I'm so stuck in the 0 to 360 range. What we're going to do is we're going to have our range going from 0 to 720 degrees. Right, so if you were sketching the curve, you'd have to think 0 to 360 and then repeat it to 720. So you can see 360 and so on, 180. And so what's going to happen here is you're going to have more solutions. So I'm going to use my cast diagram and show you how this works, because I am a big believer in the cast diagram. Right, so first of all, it's sine and it's positive. Where is sine positive? Here and here. I've circled my quadrants. What I'm now going to do is I'm going to find my acute solution. So I ignore whether this is positive or negative. I've dealt with it by circling the quadrants. This is what I love about the cast diagram. So inverse sine 0.7, I've got 44.4. That looks like a minus, sorry. 44.4. So I draw into the ringed quadrants from the nearest x-axis to those ringed quadrants. So I'm drawing in 44.4 and 44.4. And now I'm going to read off my answers. So this is the bit that's different. I start with 0 and I'm going to get 44.4, all good. And I go round and I've got 180 minus 44.4. So I've got 135.6. But I'm now going between 0 and 720. So I go all the way round to 360 and I go round again. I go round a second time. So my next solution is going to be, if I think, 360 plus 44.4. So 360 plus 44.4, which is 404.4 degrees. And then I keep going. Okay, so I've gone round and then I go round again. So it's actually, I've gone round again another 360 from 135.6. So 360 plus 135.6. My final answer is 495.6 degrees. And what you could have done is if you'd used your curve, there's one, and you'd drawn a line, well, it's a really bad drawing there. You could see from your curve that you would have got your 4 solutions, okay? And if you find the sine of any of those, you will get 0.7. Next one. Number 2. So we're now going to solve the cos of y is 0.1. And this time we're going to be looking between 180 degrees and minus 180 degrees. So let's adjust our range and let's think about how this is going to look on the cast diagram. Right, it's cos and it's positive. Cos is positive here and here. Okay, I've dealt with where these answers are going to lie. I'm now going to get my acute solution. Remember, ignore whether that's positive or negative, you just take the absolute value. So shift cos 0.1. And I've got 84.3 degrees. And as always, draw into the ringed quadrants from your nearest x-axis. Okay, we're now going to read off to find our solutions. So let's start. Here's 0. And I'm going to go all the way, but only as far as 180. So my first, I hit 84.3. And get to 180, nothing else there. Okay? So I'm now going to go from 0 to minus 180. So 0 going in negative direction. So that's minus 84.3. And I keep going to minus 180. Don't meet any more solutions. So my two solutions are 84.3 and minus 84.3. If you'd drawn your cos curve, what your cos curve would have looked like is this. Okay, between 180 and minus 180. Okay, that's what's supposed to say, minus 180. And to have solved your equation 0.1, you would have been wanting to find where they crossed there, what those solutions were. So two solutions, and again you can check them by finding the cos of both of them. Right, number 3. Messed up. Right, number 3, we're going to solve the tan of x equals minus 2, and our range, and we're going to be giving this in a different way, is going to be minus 180, comma 360. So if you remember from your work when you did your different notations, that actually means it lies between 360 and minus 180, but because those brackets are curved, it can't equal them. If I'd wanted them to be equal to 360 or 180, I would have done square brackets like that, if you remember from your interval notation, but I haven't done those square brackets. So let's have a look. Class diagram. Tan, negative. Right, where is tan negative? It's positive here and here, so it's negative in S and C. Get your acute solution. You ignore that negative, you ignore the sign, so you shift tan to, and it's 63.4. Okay, right, draw in to your nearest ringed quadrants, and let's have a different colour. Oh, that'll show up. Right, 63.4, and in from to this one from the nearest x-axis, 63.4. Let's now read off. Let's start from 0. Maybe I'm going to change that colour again. So I'm going with too similar. Right, let's go this colour. So let's start from 0. Here's my first solution. 180 minus 63.4. So that's going to be 116.6. Okay, I can go as far as 360, but not to 360. So this next one, here's my next solution. So that's 360 minus 63.4. And that is 296.6. Now I can't go beyond 360, but I can see I could have gone to minus 180. So now let's go in a negative direction. So if we head towards minus 90, you can see we hit minus 63.4. We can go as far as minus 180, nothing there. So those are our 3 solutions, okay? And this is where I think CAST comes into its own. I haven't had to draw that annoying tan curve. And what you could now do as a quick check, I will show you how to do a check another way in a moment. So what you could now do is find the tan of those 3 angles, and hopefully the tan of each of them will give you negative, was it -2? Okay, right, let's try some questions. So what I would like you to do is I would like you to go to your textbook. So it's exercise 10E, and that's on page 188. And I would like you to have a go at question 3 and check your answers. Thank you.